Good morning, good evening, good afternoon, good night, ladies and gentlemen. Well, there are many candidates this year for Molecule of the Year. There's only one molecule worthy of this title, that being thymine. Now you might be wondering, what even is thymine? Well, thymine consists of 5 carbons, 6 hydrogens, 2 nitrogens, and 2 oxygens. And it comes at a great molecular weight of 126.1 grams per mole. Now, some physical characteristics of thymine is that to our naked eye, it looks like white powder. It looks like cocaine. But I'm gonna explain to you why thymine is way better than coke. Now, it's a white powder with a melting point of 589 Kelvin and a wonderful, beautiful, sacred boiling point of 607 Kelvin. 607 Kelvin. Now, soluble-wise, it's not really soluble in water. Now, here's a picture of what thymine looks like structure-wise. It doesn't seem that great, that's what you might be thinking, but you're gonna remember that in life, it's those little things that matter. Now, while thymine is not toxic in the air, on big quantities it can act as an irritant. Now, going back to its wonderful structure, thymine consists of a single ring, but this single ring is full of wonders. If we take a closer look, the ring consists of 4 carbons, 2 nitrogen atoms, and now two of its carbons form a double bond with 2 oxygens. This leaves one of the carbons having a planar geometry by forming a double bond with another carbon. And you know what they say? You can't replicate perfection. This is the case with thymine, since thymine does not have any enantiomers. But now the moment you've been waiting for. What makes thymine so great? I'm gonna tell you that we will all be dead if there was no thymine within the world. This is because thymine is one of the 4 building blocks of DNA. Basically meaning that without thymine, we will cease to exist. And now you might be wondering, what about the other 3? Can they just not be DNA by themselves? No, they cannot. This is because of a special bond that thymine has with another one of the 4 building blocks. This being iodine. Now, iodine and thymine ensure the structural stabilization of the double helix bond, and this basically ensures the accurate genetic information of DNA. Without thymine, DNA would have errors during replication, leading to a multitude of DNA mutations. Instead, thymine is what keeps our DNA stable, meaning that thanks to it, every single living organism is what it is today. Thymine is literally the Titan Atlas of chemistry, but it has many more essential roles. For example, thymine is a biomarker for cancer, meaning that it can be used to track the process of cancer treatment on patients, and also it can sometimes be used to realize whenever somebody might be in harm, in risk of getting cancer. Thymine is literally a protector of life, since it can also be used to treat diseases, since thymine is also a big important factor on HIV medication and AIDS medication. Thymine's whole purpose is that there is life, and to protect it, and to make sure that we are healthy. Now, that seems like a very good molecule to me. Now, there's another molecule, and it wants to be thymine, but it can't. It can't reach thymine levels. That's uracil, which is one of the 4 building blocks of RNA. But let me tell you why uracil does not even come close to thymine. Don't even worry about it, bro. Basically, uracil likes a methyl, and this leads to a really unstable bond with iodine. It's trying to be thymine, but it just can't. This leads to RNA to be a really short-lived molecule. Uracil tries to be thymine, but once again, it just can't. Nobody can compare to it. Now, thymine belongs to a class of molecules called pyrimidines, which are nitrogen-containing molecules that form the 4 building blocks of our DNA. Now, the origin of thymine dates back to 1893. Where it was discovered by Albert Cosell and Albert Newman, and the way that they found it was by isolating it from the thymus gland from a calf, hence the name thymine. Then later in 1908, Levin analyzed thymine nucleic acid from the thymus glands, and he suggested that the tripartite modules of nucleic acids might build higher order of nucleic acids. Now, is thymine common? Does it come from many sources? Yes. Yes, yes, yes. Given the nature of thymine that it's found on DNA, it's literally everywhere. All the way from animals to humans to plants to the most smallest bacteria. There is thymine in there. And for the previous reasons and more, I would like to nominate thymine as the molecular hero of the year. This essential molecule is one of the 4 building blocks of our DNA. When it parties with iron, it builds a strong and stable hydrogen bond. This ensures there's accurate genetic replication. Thymine also plays a crucial role preserving our genetic integrity, allowing all organisms to pass down all of their traits that are essential to sustain our life. Without it, DNA will lose stability, threatening literally every single foundation of heredity and evolution. Without thymine, we will literally still be fishes. Fish on the seas. Radiohead. Sleeping with the fish. Something like that. In today's world, where mutations and errors can cause harmful genetic diseases, thymine ensures our safety as our DNA silent guardian. It ensures that our life's blueprints remains intact and accurate. It might be small, but it has a big heart. For us. Now, its role in protecting genetic information makes it a true molecular hero. From the most smallest simple bacteria to the most complex human, thymine is reliable, precise, and is what has kept life thriving for billions and millions of years. This earns thymine the title of Molecular Hero of the Year. Without thymine, we wouldn't have our freedom. We wouldn't have what's here. Thymine, Molecular Hero of the Year. Let's go, thymine.